something very vulnerable that is a misunderstanding I've had about what a solar system is. Oh boy, this is embarrassing. I haven't felt this embarrassed in a while on our podcast.
Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to Lesson 80. We are in our deadly solar system unit. Cheryl, where have we made it in the solar system so far?
Well, we started with the sun, our deadly sun, and then we went to deadly Mercury.
Okay.
And then to deadly Venus.
Uh-huh.
So
where does that leave us now?
Ryan, we're on Earth.
Oh, that's beautiful.
Yes. So I think...
Clearly nothing deadly about Earth.
Oh, my goodness gracious. Well, my first thought was murder.
Okay.
But
Great. Wonderful thoughts.
I think as we talk about ways you can die in space, which is our unofficial title of this unit, and we talk about Earth, it should probably still be like space related. Yes.
Okay. So ways that space can kill us while we're on Earth.
Yes. Yeah.
Okay.
And so my question is something I know so little about, which is a recurring thing that's happening as we talk about space as well. I want to know about supernovas.
Ooh, okay. Well, yeah, interesting, because there's lots of ways that space can kill us, but supernovas are kind of an exciting one.
Oh boy.
And they've been in the news for the last couple of years, off and on. I don't know if you've paid attention or not.
So I've paid attention enough to hear the word, but
okay.
But I don't really know anything beyond that. Yeah. So it's time for me to learn some things.
There's a star in the constellation Orion. I assume you're familiar with Orion.
Yeah, he has a belt.
He has a belt. Yeah. Yes, he does. And one of the star's names is Betelgeuse.
Wait, really?
Actually, yes. It's spelled totally different than the movie, but yes, it's Betelgeuse. Okay. Yep. Fun. And it's a red giant star, and it's been doing interesting things over the last couple of years, and it will eventually go supernova. And people have been saying, "Ooh, is it about to go supernova? If it does, is it going to cause all these problems? What's the deal? What's going to happen?" That might be one of the things that you heard about without knowing about it, related to supernovae.
Interesting.
So what exactly is your question, Cheryl?
I think it's just like, how could a supernova kill us on Earth? How much damage would a supernova do? That's maybe as well. Like, if it could be deadly to us, is it like exploding our whole planet? Is it landing on our planet? Is it like pushing us out of orbit? Like what's happening? Or is it just like there's like now a dent in the Earth? But most people are still going to like go on their merry way. Okay.
Well, let's get into the pre-assessment. And I think the very first question we need to ask is, Cheryl, what do you think a supernova is?
I don't know, but I think maybe it's like a really big comet. That's why like it might affect us. But if you're saying that a star might go supernova, then that feels different to me. But I was thinking maybe it's something that could hit us.
Okay. So like a big comet or something that could hit us. Okay.
Yeah.
All right. Knowing that Betelgeuse can go supernova and Betelgeuse is a star. Does that change your thought at all?
Well, it would take so long for it to get to us if it was going to hit us then, which means it's probably not that as a concern. I'm wondering, does it become another sun then?
What do you mean by become another sun?
I don't know. Well, if the sun is a star, maybe not, but does it like explode but stay big and then it's like a sun? Or does it become
What do you mean by
hole?
It's like a sun? What does that mean?
Like things start revolving around it? Like it has enough gravity that like it becomes like its own.
So when it goes supernova,
system?
It has enough gravity to have things go around it.
Maybe.
Is that what you're saying? Okay.
Perhaps.
Perhaps.
I don't want to commit to any of these things because they're all just guesses. Or does it become like a black hole and it like starts like, well, and also, Ryan, I don't know what black holes are either, but does it start like sucking things in? Is it imploding? Is it exploding? Is it blinding us?
Okay.
Is it just like really fantastic and that's why it's super?
That's it. You got it. Yeah. That's the end of the lesson. It's because it's fantastic. It's a supernova.
Yeah.
Okay. If I were to tell you that a supernova is in fact a star that explodes, would that give you any more ideas?
Well, that definitely helps. I still don't know how a star exploding could impact us on Earth because we're so far away.
Right.
Like I understand that like the light that we see from stars is in the past because of how long it takes to travel to us. And so if it's exploding, then like, is it like years and years and years before damage happens to Earth? But that damage will happen. And are we getting hit by something, or do we get to see a really cool explosion?
What do you think? Do you think we could see it?
Yeah. Well, you can see stars, so I think we could see the explosion of it. But is there information current because they've sent out things so that they actually know like today what's happening with that star, or is there information based on like the light that we're seeing here closer to Earth, and so they're learning what already happened as time goes by? Like when they're speculating that it might go supernova, which still does sound like it's becoming a pop sensation, like going platinum or something like that.
Yeah, it's gonna go supernova. It's inevitable.
But like when they're saying that might happen, are they saying that like from the knowledge that we have of the light we see today from Earth, and therefore whatever's happened already happened in the past? We're just gonna learn, or are there like things, satellites, probes, whatever we send out into space that are far enough out that they actually have like information of like more currently what's happening with this star?
Yeah. Which of those two do you think is more likely?
Well, I think it's probably somewhere in between, because I think that they do have information that's much closer, at least to planets, which is still really far from the stars. But I don't think they know right now what's happening with the star, because I don't think they've sent something all the way to a star. It would take years and years and years, right? Because it would be traveling slower than the speed of light. I forget how many years, but I know it's years and years ago that we're seeing this starlight. But then if they're so far away and the light is so tiny, then like what could it even do to us on Earth? But clearly it can do something. We're talking about it today in our deadly solar system.
We are. Any final guesses on what it might be able to do to us this far away?
I'm guessing we might get hit by an object that's like a part of the star that explodes.
Okay.
Or, yeah, does it end up being like a comet? But maybe there's more energy to it because like stars are so hot. I don't know. Those are my guesses.
I think those are good guesses. There's clearly a lot that we're going to need to talk about to get to your answer here, Cheryl.
Yeah, I actually don't know anything this time, Ryan.
Yeah, you know a lot less, which is understandable because these are not exactly the sorts of things that you have everyday experience with or hear about in casual conversation. Even things, you you may not know what momentum or inertia is scientifically, but those words you've heard and people use them and things like that. A supernova is not a thing that a lot of people tend to talk about. So I can understand. Let's just start with a couple of real quick things, and then we'll get into what a supernova could actually do. It's not a comet. Like, not even close. We're clearly going to have to talk about comets at some point in the future as well, because like, not related at all. Yeah.
Okay.
One is smaller than a planet. The other one is the size of the sun or bigger.
Yeah, no, that checks out then. Yeah.
Yeah. And they're made of very different things. Okay. Also interesting that you were talking about it becoming another sun and having enough gravity or maybe getting big enough to have its own solar system. Betelgeuse is a star already and already has its own solar system. When it explodes, it's going to destroy that solar system.
Wait a minute. Does each star have its own solar system?
Statistically, the answer to that is yes. The reason I say statistically is because no, not every star has planets around it. But we've had several missions that their whole purpose has been to map what we call exoplanets, planets that are outside of our own solar system. And when you add up the number of planets that we've detected around stars and multiply that by the number of stars, and you average it all out, there's, I don't remember what the number is now, but like, I'm making this up, 3.5 planets per star or something like that. It's more than one. Now, there's going to be some, like the TRAPPIST-1 system, I think has 7. We have 8, right? And there's some that'll have fewer planets than that. And these are just the ones that we've been able to detect. But yes, in general, you can assume that if you see a star in the sky, it probably has planets around it.
Okay, Ryan, I'm going to say something very vulnerable.
Okay.
That is a misunderstanding I've had about what a solar system is.
Okay.
Oh boy, this is embarrassing. I haven't felt this embarrassed in a while on our podcast. I thought that our solar system and the stars that we can see were all one solar system, and that was just our solar system, and that was called the Milky Way.
So that's a galaxy. And yes, it is called the Milky Way. The solar system is the system of things that go around Sol, which is the name of our star, the sun.
Okay, that makes sense. So the Milky Way is a galaxy,
which has hundreds of billions of stars in it.
And that's what we're seeing, like in the sky, obviously. I just didn't know that those stars had planets around them. I thought...
Well, we didn't know that 50 years ago.
Yes,
we didn't know that for sure like 20 years ago. We didn't know that for sure until 20 years ago. Here, let me look and see. When did the Kepler mission launch?
So it's possible when I was in elementary school learning about planet stuff, they wouldn't have covered that.
Correct. Now, we've been detecting exoplanets other ways, but we sent our first satellite into space specifically to detect exoplanets. It launched on March 7th, 2009.
Oh, so when I was done with all of the school?
Yes.
Oh, okay. That does make me feel a little better.
Yes. Now, that doesn't mean that we didn't know that there were exoplanets out there, but I don't think we had documented and had scientific evidence to support them. I think we assumed that there were, but we definitely didn't know how common they were. And we didn't have any images of them and we don't have very many images. Most of the things are measurements of effects of them as opposed to actually pictures, because they're really, really far away and really, really small, and they don't give off their own light. So that all makes it really, really hard to detect. But no, this is a relatively recent thing. That's why you don't know that.
This feels so much like when we talked about Pluto really early on in this podcast, and we were talking about how it's so interesting because scientific discoveries are still happening, But for a lot of us, we're not paying attention to those. And
right.
so what we know about science is from whatever years we were in school and whatever was being typically taught in classrooms at that time.
That's the other piece is even if you were still in a classroom in 2009, its information flows more quickly now than it did even in 2009. And we already had broadband internet by 2009 and things like that. But especially like I was in high school in the mid to late 90s. And so the internet existed, but not in the way that it does now. And so even if a discovery was made, it wasn't something that easily got broadcast to the world that people knew. So there was a delay in time between when scientists would discover something and when the general public would know that. And so for me as a science teacher, I have access to that information, obviously not like right when it's there, but pretty quickly. And I can adjust what I'm teaching my students as we learn these things. And I do. The things that I teach in my astronomy class today are not the same things that I taught 10 years ago, partly because we've been able to make these advances and we know so much more. For example, 10 years ago, we didn't have an image of a black hole. Now we have two.
Wow. I love that. That's so cool.
Yeah.
But then it sucks for people like me who just don't pay attention to scientific discoveries.
Well, that's what this podcast is for.
Yes.
All right, let's bring it back around here. So we've got Betelgeuse is a star, most likely with its own planets, its own solar system. When it goes supernova, it's going to explode. Think like bomb, because it will be like a bomb, but the size of the sun, and actually bigger than that, because Betelgeuse is significantly larger than the sun because it's a red giant. And one of the things you mentioned was, well, there could be bits of it that would run into us, but it's really, really far away. And that's correct. You remembered that well. As a matter of fact, I looked it up. Betelgeuse is 642.5 light years away from Earth. That's not particularly close. That means traveling at the fastest speed possible, it's going to take almost 650 years for something that leaves Betelgeuse to reach Earth. That also tells us, kind of like you were saying, well, is that what we know right now? Or like, do we have things that are there? No, we don't have anything that's anywhere close to that. The farthest we have are the Voyager 1 and 2 probes that were launched in the late 70s. And those have just crossed one of the ways that we talk about the edge of the solar system, but they're not even like halfway between the sun and our next closest star. So,
wow.
And that's 4 light years away.
Time.
So yeah, it hasn't even, I don't think it's even gone 1 light year yet. So we're not anywhere close and it's gonna be a long time. However, when we see light, because when it explodes, Betelgeuse, we will see it. And historically, we have seen supernovae in the sky. Basically, the star gets really, 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 really bright. Sometimes so bright that you can see it during the day.
Wow.
Yeah.
That's so cool.
Yeah. I would love to be able to see one during my lifetime. I have 0 ways of controlling that. And I think the chances are relatively slim that it will happen, but it would be very cool. I would love to be able to do that because it would be just really cool and really unique, but also scary because that's a huge amount of energy that you are exploding out into space. Now, we don't need to worry about what they call the kinetic debris. That's the actual physical stuff that the star is made of that you mentioned that could hit. And that would be something, it's not made of the same stuff as a comet, but a similar sense of like physical things actually coming down onto the surface of the Earth.
Yeah, okay.
We don't need to worry about that from a star like Betelgeuse. Although if you're close enough to a star that goes supernova, that is something you have to worry about, is the actual kinetic impact of the physical debris from the star.
Interesting.
We don't really need to worry about that here. Some of the other things, though, is stars within about 500 light years of Earth that go supernova, they can be so bright that at night it doesn't really get dark, and that can mess up the day-night cycles of animals and plants and things.
I didn't even think about that aspect. I just thought, oh, it would suck to try to sleep. But for things that actually rely on day and night and don't have like artificial light and artificial darkness.
Right.
Whoa.
So that's a potential factor, optical light. There's a bunch of other things, and I don't know that I need to get into all of the details of what they are. I'm going to list them relatively quickly. But if you want to know more about them, you can add them to the list and we can learn what they are later. There's these things called neutrinos. There are gamma rays and X-rays that you might have heard of before, and cosmic rays. All of these are things that are emitted when a star explodes as a supernova, and they can do a bunch of different things. Some of them, if the star is far enough away, our atmosphere can actually absorb them. But some of the things can actually destroy our atmosphere and break it apart, which means then any of those other things could potentially get to the surface of the Earth. And if you have things like X-rays or gamma rays reaching the surface of the Earth, they could like burn you and fry you and damage your DNA and cause cancer and all sorts of really, really terrible things and mutations and things like that. Wow. Now, we don't really have to worry about these anytime soon because there aren't really a lot of stars that are close enough to going supernova, close enough to us that we really need to worry about it. Technically, Betelgeuse could go supernova in the next 100 years, but it could be several hundred to 1,000 years before Betelgeuse goes supernova. And it's not really close enough to cause those huge amounts of damage or be so bright that it can mess up day-night cycles and things like that. So it's not really a huge concern. Now, if you give all of time with the planet Earth and we just say, look into the future for millions of years, it's a inevitable guarantee. Like it is going to happen at some point that a star close enough to us will go supernova that will cause damage to things on Earth. Like that is going to happen eventually. And we're pretty sure has happened in the past. And we think some of the mass extinctions, now I'm trying to remember if there were 5 or 7 great mass extinctions over the Earth's history. And I don't remember the number, I'd have to look it up. But at least 1 or 2 of those we think might be the result of a supernova, at least partially. Yeah.
Interesting. How so? Like, what about it?
Just, weakening the ozone layer, increasing the like mutation rates and things like that just wipes out the less strong organisms. And we think extinction and we think of the dinosaurs and the asteroid that hit and this one cataclysmic event. Most extinctions took thousands, if not millions of years to actually occur. And so it's not like it happened at this one moment. It's over time, organisms died out. And so it's still considered a mass extinction because of the number of organisms that died, not necessarily how quickly they died out. So
interesting.
Yeah.
That's really interesting. But how do scientists know that a supernova might happen? Like what evidence do they have that makes them think that?
Yeah, the short answer is we know the life cycle that stars go through. We know the process that stars are, like where they start, how they change, why they change, and what happens as time goes on. And we can look at stars and see where they are now and measure things about them, like their mass. And we can say, oh, this star is massive enough that it's going to go supernova. For example, our sun isn't massive enough to go supernova. It never will go supernova. It just doesn't have enough mass. It's not big enough. Whereas other stars, if they are big enough, eventually they will go supernova. There are scientists who their entire job is to study supernovae, which is the plural of supernova. And they use telescopes to map supernova explosions in other galaxies. You talked about the Milky Way earlier, right? Yeah. It's our galaxy. When a star goes supernova, it releases so much energy that that one star will outshine all of the light of all of the stars in the rest of the galaxy.
That's so much.
It's so much. What that means is we can look at a galaxy that is millions, if not billions of light years away, And if a star goes supernova, we can see it. Because that's how bright it is. That's how much energy is given off. And there are scientists who study those. They map them, they keep track of them, all of those things. And so there's also scientists who study stars more like just in the Milky Way and are tracking those things as well. And so, yeah, does that answer your question as to how we know?
Yes. Wow, that's fascinating. That's so cool.
I think so. Now that you are a supernova expert, Cheryl, I think it's time for your quiz. Yeah.
Yeah, no, that's totally fine. I'm about to go supernova myself. I'm such an expert. So.
Oh, wow.
But in
Congratulations.
This case, it means platinum. I'm really going to blow up. So. Yeah.
Just going to blow up. Yep. All over the socials. All right. First question. What is different between a star, a solar system, a galaxy, and I'm going to throw one in that we didn't talk about, and a universe?
Oh.
How are they related to each other?
Well, I think there's one universe.
Okay.
So that's everything.
Okay.
That's what I'm going with. There are more than one galaxy, but a galaxy is made up of a lot of stars, constellations, but I think constellation sounds more like a man-made term. And I mean, all of these are man-made terms for things happening out in nature, but like, feels like maybe constellations are not like because they naturally are grouped that way, but because we see them in that way, but maybe not. We didn't talk about that. That's just a guess for fun. But yeah, galaxies are whole bunch of stars, billions. Solar systems, it's one star with planets that go around it. And then what was the other one?
Star.
A star is, I don't know how to define a star.
It's fine. You
big
in relation to each other, you already used it.
Very bright.
Yep.
Massive, enough of a gravitational pull that things go around it.
Yeah. Close.
Lots of energy.
Lots of energy. Yep. You know, during thermonuclear fusion, that was the part that you were going to say that you forgot.
Yeah. That's what that's what I was covering with like brightness and energy. Yeah. Totally.
Yeah. And just because you need more new things in your brain right now.
Okay. Yeah.
A solar system actually doesn't have to only have one star. You might actually have 2 stars or 3 stars. And actually those do exist too.
How?
That's a question for another time. It's a question for another time. Write it down.
Goodness gracious.
Next question. What is a supernova?
A star that blows up.
There you go. Bingo. Question 3. Why would a nearby supernova not be like a comet impacting Earth?
It would be a lot more elements than a comet impacting Earth.
What do you mean?
Well, the comet, it would just be the object and it hits us. End of story. But the supernova, well, it's much farther away.
Yep.
And it might be close enough that we could have objects of like pieces of planets hit us, or probably pieces of the star hit us. But sounds like more likely is that all these really crazy rays coming out of this exploding star create more complex problems than that. Like
which leads to question 4. Yeah, question 4 is, how could a nearby supernova be a threat to life on Earth? So please continue.
Okay, great. Cancer. I'm telling you, we don't like it.
No.
Or
0 stars, do not recommend.
Yeah, we could get fried. We could get there was something that sounded similar to fried that you said. And our DNA could get all messed up from it, which sounds like a bad experience and a poor way to live at that point.
Well, you don't live very well
beyond that. Yeah.
No, not if it gets messed up enough. You don't live for very long. Yeah, no.
Gross. Okay. We could like lose our atmosphere or chunks of it at least. And then we could all die. It's not like the planet would stick around.
Most likely,
the physical planet.
Yeah.
But life on the planet. Oh, and then it could, if it was bright enough, create like a false daylight at nighttime and mess up plants and animals and their whole deal.
Mm-hmm. And their whole deal. Wow. Yes. Yeah. It could mess up their whole deal.
It could.
Okay. Last question. Do we need to worry about Betelgeuse, the star, not the character, going supernova and destroying all life on Earth? Why or why not?
Well, I just think we shouldn't worry so much. So I'm going to say no, because chill out. But probably more of a real answer to that is that it's so far away that we would probably just see a pretty show in the sky and not actually be impacted physically or fancy rays wise by it. And then also definitely not in our lifetime. Not that we shouldn't worry about the future and future generations and everything, but it sounds like not for like we will not see it happen, it sounds like.
Right. Most likely. Technically, it's possible. It's just a very, very small chance that it could happen within the next maybe 100 years, but most likely it's going to be longer than that. So, yeah. Great. See, I told you, you're a supernova expert.
Oh boy. That was that was a rougher one, just because I really didn't know anything, but really fun to learn something like genuinely new for me.
Yeah. And I'm going to do a recommendation. I'll put a link in the description, but if you want more details about how a supernova could destroy all life on Earth and the more specifics about the chances, there is a book called Death from the Skies.
It's so cute.
Yeah, thank you. I didn't actually make it. The Science Behind the End of the World. And there's an entire chapter in this book that just talks about supernova explosions and what they would do to Earth. It's actually written by Dr. Phil Plait, the same guy who does the YouTube crash course videos that I referenced earlier when we did our Mercury one and we watched that clip. That's the same guy. So he does a great job of explaining things. So if you're interested in more information about that, that would be a recommendation. But we are out of time for this week's lesson, Cheryl. So why don't you pack up your stuff and get ready for my closing remarks. You can follow us on Instagram and Facebook at I Slept Through Science, or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.